So, just now we verify rule P, rule T, and how the rules are executed in our own way. In the theory of inference, there are 4 type of laws are there. One is called as a law of detachment or modus ponens rule. Sometimes the directly bits are asking on this. What is modus ponens rule? It is so easy for us. Just now I discuss. I know that P is true. I know that P implies Q is true. What is your solution? Just now I mentioned Q is true. So, if P is true, P implies Q is true. By using these two, I get the Q value is true. This rule is called as a modus ponens rule. Modus ponens rule. Okay. Next, I already proved how I will get this one. Next one, law of hypothetical syllogism or transitive property. What is the transitive property? I know that P implies Q is true and Q implies R is true, then I can written this as P implies R is true. P implies Q, Q implies R, I get P implies R is true. This is called as a transitive properties. Next, there is another law that we call as a Demorgan laws. We already know the Demorgan laws. Negation of P and Q can be written as negation P or negation Q. Negation of P or Q is equal to negation P and negation Q. These two are called as a Demorgan laws. Demorgan laws. Next, law of contrapositive. What is the law of contrapositive? You see, suppose I know P implies Q is true and negation Q is true. What is your answer? What we will get? P implies Q is true, negation Q is true. What we will get? Right? Don't try to by heart. It's so easy. So, what is our data? P implies Q is true, negation Q is also true. So, in the solution, first I may consider negation Q. Again I am telling that there is no restriction that you can select only second one is first. No, you can take any one as a first. So, for simplicity purpose I am taking negation Q. From this what I know? Negation Q. Once I written here means it is having a truth value T, where you are taking from the premises, therefore I written as a premises rule P. So, negation Q is true means indirectly Q is having truth value false, that is the meaning. Now, from this I do not know any, I am not getting any information. So, I can apply P implies Q. P implies Q. This is also I take from the premises. Now, P implies Q is having truth value T. When P implies Q fails, first one true, second one false. In that case it fails. Okay. So, but here I written P implies Q is false. P implies Q is true, and from this step number 1 I know that Q is having false. So, from step number 1 I am fixing the value of Q is false. If Q is false, what is the restriction? Suppose if P becomes true, this entire statement fails. Therefore, there is only one chance that P should be false. P should be false. P should be false. So, from the statement 1 and 2 what I am getting? I am getting that P is false. I am getting that the truth value of P is false. But false statements cannot be written here. Therefore, if P is false, negation P should be true. Negation P should be true. Therefore, P implies Q is true, negation Q true. What is my answer? Negation P is true. This is called as a law of contrapositive statements. Law of contrapositive statements. Okay. So, once you know the rule P and rule T, there is no necessity to by heart any one, but sometimes they are asking the direct steps, direct names. write the modus ponens rule, write law of hypothetical syllogism, like that I have to mention. So what is the law of detachment? I know the value of P is true, P implies Q is true, therefore I get Q value is true. This is called as a modus ponens rule or law of detachment. Next, this is called as a transitive law. P implies Q true, Q implies R true, therefore P implies R is true. This is called as a transitive property or law of hypothetical syllogism. Next, these two are called as a Demorgan's laws. Negation of P and Q is equal to negation P or negation Q. Negation of P or Q is equal to negation P and negation Q. So we will get these two laws I called as a Demorgan's law. The last one is called as a contrapositive law. Just now I explained how we will get this. P implies Q true, negation Q true means Q is F, Q is F means P should be F, that means negation P is true. Once you get this logic, you can solve n number of problems given in the examination. Okay. Now we will take 1-2 problems. How we will implement the, how we will verify whether the data is correct or not. Okay. Okay. We will take some more examples. Observe this example. What is the question they are asking? They give some premises, find the conclusion. So, what are the premises? Negation of P and negation Q or R, negation R. These are the three premises. By using these three premises, what is your conclusion? What is your logic? Okay. So, I can say this is a premises number 1, this is a premises number 2, this is a premises number 3. Now, to get the solution, what we are doing, I can apply the premises maybe 1, maybe 2, maybe 3 as the first step. So, this is depend upon you. You may take this one, you may take this or this. Suppose I am taking negation Q or R. This is the premises what I am considering, where we are taking from the premises, Okay. Now you observe, can I get any information from this? Shall I write like this? Q implies R. Why I have to written like this? Because P implies Q is equivalent to negation P or Q. So, in the place of P, Q is there, in the place of R, Q means this is in the form of negation Q or R is in the form of P implies Q by using this formula. Next, so once I write in what is our assumption, this is having a truth value T, but it is not given in the premises. So, if you want, you write it as rule T. Next, take down the next term. So, I have already used this. Once use the premises, so it may not be allow you to use once again. Every premises should be used only one time. Now, I am taking the next one, negation R, where you are taking again from the premises. Now, by using these two steps, can you get any conclusion? We will see. Negation R is having a truth value T. Who says once I mentioned it in the data means a premises, this is having truth value T. So, negation R is having a truth value T means what is R value? R should be F. So, from this, in this value, R value is a fix. R value is fixed, that is R is F. Then, in Q implies R, R value is fixed as F, but I know that Q implies R is having truth value T, then if Q is true, what about the Q implies R? It should be fail. Q implies R, first one true, second one fail, it fails. Therefore, Q should not become true. So, Q should be false. False implies false is true. So, we know from these two steps, I know that the truth table or truth value of Q is false, but Q value is false, it should not be written, so I written as negation Q. negation Q. It is obtained from U. This is rule new appearance. Next. Now, one more premises, negation of P and negation Q. Negation of P and negation Q. Try to implement a Demorgan law for this. Negation P or negation of negation is Q. Now you try to use these two steps. I know that negation Q is true. So what is the value of F? Q is truth value of Q is F, but negation Q, negation P or Q is true. I know that the value is F. So what about this? When R is true, P or Q is true. If either P is true or Q is true, but I fix this value is fix F. So there is a chance for me that only P is false, P is true, therefore negation P is true. So what is your logic or conclusion from this? All these, the answer is negation P is true. Okay. Now, the next question, we will come to the next question. R and P or Q is a valid conclusion from the premises. They are giving some premises, 1, 2, 3, 4 premises are given. From this, have you get this conclusion or not? That is the question. Is a valid conclusion or not? We will follow the same steps. In step number 1, you can consider any one. Suppose I may consider first one is P implies M. Okay, P implies M. From P implies M, I am not getting any information. Only one thing is P implies M is having truth value T. So I consider negation M. Negation M. So if I consider negation M means what is the truth value of negation M? Is true. If it is true means it should be false. If it is a false means P should be false. Therefore, from these two I get negation P. If you get some confusion, I already give some laws. P implies M and negation M, we will get it as negation P. Is a contradictory formulas. Or P implies Q and negation Q, I get negation P. That is a last rule, converse laws. But it is easiest way. P implies M is true. Negation M is true means M should be false. M is false means P should be false, but false should not be written, therefore I written negation P. These, by using these two steps, I get this new step. Okay, so I am using this, I am using this. Now I am taking P R Q. This I am taking this one, P R Q. Now you compare 3 and 4. By comparing 3 and 4, I know negation P is true. That means P should be false. This is false. If P is false, Q is also false. This fail. But they give P or Q is true. Therefore, negation Q value should be true. So Q value should be true. By using these two steps, I get this. Next, I have only one more. That is the Q implies R. Q implies R. Q implies R. Okay. Now, compare these two. I know the value of Q is true. I know the value of Q is true. If R is F, true implies false is always a false. But I know that this value is true and I know the value of Q is true. Therefore, R should be true. Therefore, R should be true. R should be true. So, I know the value of Q is true. Q implies R is true. Q implies R is true. Q value fix it as a T. Therefore, R should be true. Now, I know the value of R is true and I know the value of P or Q is true. I know the value of P or Q is true. So, if P is true, Q is true, P and Q is also true. From step number 7 and step number 4, what I am getting? R and P or Q is true. Therefore, the answer is correct. That means, by using these premises, whatever answer I am getting or given in the problem is a valid conclusion. It is in this way we will get the solutions easily. Okay, we try to solve one more, then we go for the method of syllogism. Okay, so better try to understand the truth tables clearly, and once you have a good grip on truth tables, you can solve this problem so easily without by hearting any. We take down this problem. They give the premises: negation P implies Q implies negation W, negation S implies Q, negation T, negation P or T, it logically follows W implies S. That means we have to verify whether this conclusion is logically follows from this or not. Some certain times we may not implement rule P and rule T, we may get some confusion, or we can solve these problems by using indirect proofs or method by contradiction, what we called. Now first we try to explain what is the method of contradiction. Suppose I have a premises H1 is one premises, H2 is another premises, H3 is another premises, like that Hn are premises which follows a conclusion, say C. H1, H2, H3 Hn are premises, there logically follows a conclusion C. I want to verify whether C is a valid conclusion or not, means direct procedure is one method. Now I try to implement a proof by contradiction. What we will do, take the negation of the premises as an extra premises, take the negation of the conclusion as a extra premises, extra premises. That means what I am getting, H1, H2, H3, these are all given premises in the problem, and I may add extra premises, that is a negation of C. What is this? C is a conclusion, I take a negation of this, and by taking this as an extra premises, and you have to follow logically and prove that it is a consistency. Consistency means the argument is invalid. We will prove that it is inconsistent. It is inconsistent. How? What is the inconsistent? How can we observe that the system is inconsistent? Means in the solution you may get the answers like this: H1 and negation of H1. In this way, if you get this, H1 and negation of H1 both are true, means meaningless. Therefore, this is called as a contradiction. Contradiction means, from this you see, suppose I get P and Q is true, what I say? P true, Q true, then only this is true. P truth value is true, Q truth value is true, then only P and Q is true. So in certain stage, if you solve the problem, at certain stage if you get this type of steps, H1 and negation of H1, H1 true, negation of H1 true, this is not possible. That means, what is your assumption? Negation of C is a false. How can you say that it is false? I am taking negation of C is an extra premises. Premises means this negation is having truth value T. Means finally I get the conclusion is it is wrong. Therefore, I say that C is a valid conclusion. This is called as a indirect method proofs. Once again we try to explain. Suppose H1, H2, H3 Hn are the premises. We try to verify whether C is a valid conclusion or not. I can implement the method of contradiction or indirect methods. So what I am doing, take the negation of the conclusion as an extra premises, and you follow the rules and regulations, that means rule P, rule T something. In the finally I will prove that the system is inconsistent or contradictory took place. That means in your solution you will get this type of steps, a variable and its negation, both are available as a true. Therefore, my conclusion is correct, means my assumption is wrong. Now you see, this is a given problem. 4 data is given, 4 premises, I have to take this. Now I want to prove this by using the method of contradiction. Method of contradiction means what I mean, this is my C value, this is my C value. So first I have to consider negation of C. So if C is equals to W implies S, It is in the form of P implies Q. P implies Q can be written as a negation P or Q. So, C can be written as negation W or S. How? P implies Q. We know that P implies Q is equivalent to negation P or Q. I know this formula. In the same way written. Now, what we will do? Take a negation of C. That means a negation of negation W or S. What is this? Negation of negation W means it you have tried to implement Demorgan law. Negation of negation is W or converts into and negation of S. So, this is a negation C. So, in the given data, if I want to verify the logically, the conclusion is logically correct or not, first I will take the negation of the conclusion. Now, what is the next step? I have to take this as extra premises. So, I have to define the problem like this. What we will get? Negation P implies Q implies negation W, negation S implies Q, negation T, negation of P or T, and now you add this as extra premises W and negation S. So, these are all our premises. By using these premises, I have to prove whether it is correct or not. So, P1, P2, P3, P4, P5, you can consider any one. So, better first I may consider W and negation S. It is easy for us because just now I explained P and Q is true means P true, Q true. So, from this what I can get? W true, negation S is also true, negation S is true. Okay, next I will, so this is used by me. Now, you can consider any one. Suppose I may consider the term negation S implies Q, negation S implies Q. I consider this premises now. Take down compare these two steps. What you get? I know that negation S is true, negation S implies Q is true, negation F is true means I fix this value is true. So, Q should not become false, Q should be true. Therefore, by using these two I get it as Q, okay. From these two steps I get this one. So, which steps you are using here? Step number 2 and step number 3. Next, you consider the next term negation, negation P implies Q implies negation W. Okay, first premises. So, in this one what you know? You know the value of Q is true, W is also true. Q true means what is a Q value is true. What is the W value? W true. So, negation of W value is F. That means the entire value of this is F. Am I right? First one true, second one false, T implies F is always F. So, what you say? I fix this is F, but I know that negation P implies Q implies negation W is true. So, when it is true, so negation P should not become true. Negation P should not become true means if negation P become false, then only this entire statement is true. That means negation P value true means I may get the value P is true. Okay. So, by using the statements, which steps you are using? I know the value of Q, I know the value of W. By using these two steps, I get this one. Okay. So, I know the value of P is true. Next, what we are going to calculate now? You consider negation P or T. Okay. So, I know the value of P is true. So, what is the negation P? It should be false. If it is false, T value should be true. So, by using these two, what I am getting? I get the value of T is true. but in the problem they given one more step, negation T is true. Negation T is true. So, by my logic I get T value true, in the problem they get negation T is true. So, what we will get by using these two, T and negation T is true. T and negation T is true means which is not possible, because the T is having truth value T, negation T is also having truth value T, means it is not possible. So, this is called as a contradiction. So, contradiction means our assumption is wrong. What is your assumption? Negation C is a true. Your assumption is negation C is true. Who says I am taking negation C as an extra premises? Extra premises means this is having truth value T. Truth value T means it is a valid, but negation C is not a valid. If it is a valid, I am not getting this step. That implies negation C is not a premises. Not a premises, implies C is valid conclusion. C is a valid conclusion. So, this is a one of the wonderful methods to check whether the given conclusion is valid or not. You can apply direct method. Sometimes you may feel it is more comfortable, take this as an extra method by contradiction. What is, once again we try to explain what is the method by contradiction. Suppose I have h1, h2, h3 dot dot hn are the variables or premises. We have to verify whether C is a valid conclusion from the data or not. What we will do? We take the negation of the conclusion as an extra premises, and you follow the logical inference theory. Finally, we prove that it is not a valid. It is not a valid or it is not possible, means negation C is not a premises, implies C is a premises. This is the logic or algorithm behind the subject. Now, once again you go through this question. They are giving 1, 2, 3, 4 premises. You have to verify whether C is the logically followed premises or not. Means what I do? First I take the negation of C. Negation of C can be written like this. I take this negation C as an extra premises, and the premises can be converted like this. Now, I will go step by step. First I will take this one, W and negation S, means I know that W is true, negation S is also true. Next I will consider one more premises, negation S and Q. From this I know that negation S is true, means Q automatically become true. Next I will consider this premises. From this premises I know the value of Q is true and negation W should be false. So, T implies F is false, therefore, the total truth value of this term is false, but I know that the entire truth value of this is true, therefore, negation P should be false, then only this is true. So, negation P is false means P is true, but they give in the problem that negation P or T is true, means if P is true, negation P should be false, therefore, T should be true, therefore, I get T is true. But in the problem they give a negation T is true. So, T true, negation true is not possible or it is impossible, therefore, my assumption means negation C is extra premises is wrong. That means C is a correct answer. This is the method what we follow in the method of introductions. Okay. Now, we will see this question. What they given in this question, this is given in 2013 question paper. H1, H2 are two premises, C is a conclusion, then consider the arguments. So, they give a H1 value, H2, these two are premises, C is a conclusion. So, which of the following is correct? That means answer A or B or C or D. We have to verify. How we will solve this problem? It is easy for us that you write down the H1, H2 premises. H1, H2 premises. Right. What we are taking this? What is our H1? P implies Q implies R. This is the premises 1. Premises number 2. P and Q is true. So, the answer what we will get is R. Is this is correct or not? Is it a logically follows or not? We will see. The first one, this is a problem 1, this is a problem number 2. In the first problem they give 2 premises, a conclusion is given, even in second also 2 premises are given, C conclusion. Now, we have to verify whether answer A is correct, B is correct, C is correct, D is correct, or that is our main motto. First I am taking the problem number 1. So, in the problem 1 they give 2 premises. Now, I try to solve this. So, first I consider P and Q. Consider P and Q. Once I written it as a premises, what we will get from the step? I know that P is true, Q is also true. P and Q true, if both P and Q are true. So, I write P, Q true. Now, I consider the next step, that means P implies Q implies R. P implies Q implies R. Once I written here, what is the truth value of this? It is true, and I know the value of P is true, I know the value of Q is true. Okay. Now, you see, P implies Q, you see, P implies, I know that this is Q, P implies Q. When we get P implies Q is true, if P true, Q false, then fails. P true, Q should be true, then only it writes. So, by using these two, by using the step 2 and step 3, what I get, and I know that Q implies R is true. Q implies R is true. By using these two, I get this. Next, I know the value of Q is true. Q is true means R should be true. R should be true. Once again, take the premises number 2, P and Q. From this I know that P true, Q true. Next I consider the premises 1, P implies Q implies R. It is in the form P implies Q. You treat this as Q. I know the value of P is true. So, Q should not be false. That means Q implies R should be true. Therefore, I written here Q implies R. But I know the value of Q is true. If Q is true means R should be true. That means our answer is correct. So, 1 is correct. Come to the second one. What is the second problem? They given H1 value is negation P, H2 value is PRQ, then P and Q is logically correct. You have to verify. We will see. So, first I consider negation P is true. This premises I consider. Now, from this I know that negation P true means P should be false. Consider the PRQ. Consider PRQ. Negation P true means P should be false. P should be false means Q should be true. Q should be true. But what I can say, negation P and Q is true, because this is true, this is true. So, this is not valid reason. So, 1 is correct, second one is wrong. So, what is your answer in this one? 1 is valid, second is not valid. So, answer is this. In this way, we have to verify. Okay. So, now we will take some problems. What type of problems we will consider? Up to this stage we are giving symbolic notations. Sometimes in the examination they give it as a data. So, what type of data? Birds can fly, all birds has wings. Then what is the conclusion you are getting? That type of data is given. We have to verify whether our logically inference is correct or not. Some certain stages, at some certain stages, we can apply some another rule. What rules are how to know up to this stage? We know rule P, and rule T. What is rule P? Whatever premises they are giving, you assume that it is a true, and at any certain stage in the problem you can implement the premises. based on the premises you will obtain a new formula that is called as a theory of inference or rule T. But some certain stages we may assume it as a CP, conditionally proof rule, CP rule, conditionally proof rule. So, we may assume that, for example, you see at certain stage of the problem I know only P implies a Q. I know that P implies a Q is true, but I do not know what is the truth value of P and what is the truth value of Q. But I know that P implies Q is true. In that cases, in certain stages, I fix the truth value of P is true. I fix the truth value of P is true. So, once I know the value of P is true, I can easily guess the truth value of Q that should be true. So, here what I am doing, I am conditionally giving or conditionally assumed that the truth value of P is true. So, some certain stages we can use CP rule, that is a another model. So, rule P, rule T and CP rule. CP rules are used to get the conferences or conference or valid conclusions. Okay. So, we will discuss the type of problem here. Now, we will consider this problem. They give some data. We have to verify whether C is logically follows it or not. So, what we are doing? They are giving 3 premises, premises 1, 2, 3, we have to verify whether it is a logically follows or not. Now, we will verify this. What is the difficulty you can clearly understand. First, I am considering negation or P. I consider this. Where you are considering this one? From the premises. So, it is in the form negation P or Q. So, what I can written? This can be written as or implies P, because I know that P implies Q is a negation Q, sorry, negation P or Q. Okay. Next, have you got any information from this? No. Suppose I may consider one more premises, that means P implies Q implies yes. I may consider this P implies Q implies yes. P implies Q implies yes. From this, have you get any information? No, because this from this I am not getting logically anything. From this I am not getting logically anything. Only one thing I know, that or implies P is true, P implies Q implies yes is true. In that case, what we do? Consider one more premises, that is Q. Okay. So, I consider this is known. What is this? Suppose I know the value of Q is true, can you guess the truth value of yes? No, because it is in the form P implies Q. I do not know the value of P, I do not know the truth value of P. So, we can't guess anything. In that cases, what we will do means I can implement, I have no any other premises. So, I can assume that P is true. I can assume that P is true. Who says this is my condition? That is why I call it as a CP rule, conditionally premises. So, I may assume that if P is true. Now, you come to the step number 3, if P is true, it should not become false. So, that means from step number 5 and 3, I get Q implies yes is true. I get Q implies yes is true. Okay, Q implies yes is true. But I know the value of Q is true. Q is true means yes should be true. Yes should be true. Okay. Next, can you get anything from the information from R and P? I know the value of P is true. So, can you guess anything the value of R? If it is true, in that case it is true. If it is false, also it is true. So, I can guess that R is also having truth value. So, this is again my conditional. Sometimes we may take the conditions. So, in that case R is true, yes is true. So, I can get R implies yes is true. So, the main motto of this problem is how to involve the conditionally premises. And one more important, for which type of functions we can apply. If once I try to implement the conditional proof, the given premises should be in the form of P implies Q. In that case only you assume that P is true. This you do not assume that it is true. That means the CP rule should not be implemented for the consequent. CP rule should be implemented only for the data or necessary condition. I think you can understand the CP rule methods. Okay. Now we will see this problem. They give some data. Now we have to verify whether the data is consistent or not. What we have to do now? Is this data is correct? If this data is correct, or we give the valid conclusion from this. So what we will do now? You go through the problem carefully. If Jack misses many classes through illness, then he fails high school. That is the first sentence. If Jack fails high school, then he is uneducated. That is second sentence. If Jack reads a lot of books, then he is not uneducated. Third sentence. Jack misses many classes through illness and reads a lot of books. This is the fourth one. What we have to do? We will verify whether the data is consistent or inconsistent. So, to solve this type of problems, first you have to verify how many number of different statements are there. Statement or negation of the statement, you may consider it as one. So, you go through carefully that first sentence is Jack misses many classes through illness. That is the first sentence. So, I can write the how many number of different statements are there in the problem. There are 4 lines or 4 statements given. Among these lines, how many different sentences are there? First, you have to bifurcate. What is the first statement? Jack misses many classes. Jack misses many classes through illness. Through illness. That is the one statement. What is the another statement? He fails high school. He fails high school. He fails high school is a one more different. Next, Jack fails high school. It already came. So, it is a negation of the sentence. No need to write. He is uneducated. This is different sentence. So, Jack is uneducated or he is uneducated. He is uneducated. This is third different sentence. Next. But it come to third sentence. If Jack reads a lot of books. John reads a lot of books is a different sentence. So, Jack reads a lot of books. Jack reads a lot of books. So, there are 4 different sentences. By using these 4 different sentences, the remaining has to be formulated. Now, I can give the names for this. This is statement P, this is statement Q, this is statement R, this is statement S. Okay. So, carefully observe. If the data is given, first you have to identify how many number of different statements are there in the data. First you bifurcate all the different statements and give the names like P, Q or S. In my problem, I have 4 different statements. Now you formulate the mathematical or symbolic notations of each statement. The first statement you observe, it starts with if. It starts with if and then. If then means what you are observing? You have to apply P implies Q. You see, if P, this is P, then Q, he fails high school. So, what is the first sentence they are giving? The first sentence is in the form P implies Q. This is the first premises. Come to the second statement. Again it starts with if. If Jack fails high school, Jock fails high school is represented by the sentence Q. If Jock fails high school, then he is uneducated. He is uneducated. He is uneducated. Third one, if Jock reads a lot of books, again it starts with if. If Jock reads a lot of books, Jock reads a lot of books is indicated by yes. Yes implies if Jock reads a lot of books, then he is not uneducated. He is not uneducated. He is uneducated means represents or, not uneducated means negation of or. Next, fourth one, Jock misses many classes through illness and reads a lot of books. Jock misses many classes through illness is represented by P, and reads a lot of books means yes. This is the data. Now, by using these premises, you have to verify whether it is a valid or not. Valid means a consistency or not. We will verify. How it is possible? Take down first statement. I can consider P and yes. Consider this premises. From this what I am getting? P true, yes true. P true, yes true. Now I consider P implies Q. So I know the value of P is true. So Q should be true. Q should be true. Next, I consider Q implies R. I know the value of Q true. Q true means R should be true. So I get R is true. R is true. Okay. Next. Now I consider I have only one more premises. Yes implies negation R. Yes implies negation R. I know that yes is true. Yes is true. So negation R should be true. Negation R should be true. What you are getting from 6 and 7, R is true, negation R is true, means data is inconsistent. Data is inconsistent. How can I say a variable and its negation both are available in the proof? We simply say that it is inconsistent. This is the way we will solve the theoretical problems. Okay. So, next topic is unit number 2 is called as a predicate calculus. Okay. Predicate calculus. There also we will solve number of problems related to data. Okay. So, if you have any doubts, you please mail to the concerned administration persons.